vama svima što ste ovde. Isto kao što je... Hvala lepo, profesor. Hvala lepo. Isto onako kao što je uvaženi ambasador švedski ukazao čast nama svima ovde, govoreći srpsko-hrvatski jezik. Ja ću preći na engleski zbog gostiju i zbog internacionalnog karaktera ovog kongresa, pored nacionalnog. You know, I cannot tell you how much pleasure I have when I come to Belgrade. Obviously, you see that my native language is Serbian. I was born here. I was raised, educated at University of Belgrade, School of Mechanical Engineering. One of my professors was also Professor Todorovic. And it makes me almost a goosebumps, and I feel it right now, when I'm here and talking in the Congress that lasts as long as my professional career. I was growing with these conferences, honing my presentation skills and meeting many people from all around the world. And now I'm coming here to tell you something what is happening in the United States as a kind of indication of what is happening all over the world. I will have 3 presentations at this conference, and tomorrow in 2 other I will be a little bit more technical. I wanted to have something a little bit more generic in this first presentation. So let me start. You see I have probably 3 hats at least. I'm professor at the University of Illinois. I am president of a vibrant R&D company, CTS, and I'm director of ACRC, Air Conditioning Refrigeration Center, which is over 100 people, probably the largest center for HVAC research in the HVAC industry. And today I'll try to be kind of, as I say, a little bit superficial and generic to make this presentation interesting to a wider audience. What is happening in the U.S.? I would say environmental issues is a drive. Current USA administration is very slow in following environmentalistic trends in Europe and Asia, in both requirements for lowering GWP and increasing efficiency. But nothing unusual is that California is pushing harder than other places. This is something we have seen over and over. What is new is that this time California is getting support from various mostly developed states with a strong industry and a strong R&D in our area. As you see in the screens, Washington State and Vermont recently passed legislation following California's SB 1013. New York, Connecticut, Maryland, Delaware are going the same way. What is new and very interesting in my mind is that industry is now way more open to the changes than the administration. This is kind of pretty unusual because industry knows, in my mind, that things will change. Industry has to think about their products that they should sell all around the world and not only following the regulations within the United States. As I said, California is the leader, and they have declared the push towards electrification, basically migrating from gas as an energy source. What that means is that there is a significant effect on development of various heat pumps in their system. Heat pumps for hot water, high temperature heat pumps, even steam generation with a single stage vapor compression system and so on. There is also reduction of GWP required increase in energy efficiency, but California pushes low GWP refrigerants with strong interest in natural refrigerants. And I will give you some examples from residential, commercial, heat pumps, and a little bit in chillers. And I will give a little bit more information about what is going on in industrial refrigeration, which is not necessarily pushed by California. Even that is also coming in a sense from California. In residential system, you can expect this month that California will limit GWP to less than 750 for the systems over 1 kilogram of charge used in a new stationary air conditioning system. Start will be in 2023. Oops. I'm trying to see trying to find the, okay. Anyway, it is difficult to use the pointer. So pointer is probably, no, this is not the pointer. Anyway. Can you help with the pointer? Please. So, what is going on? Let me see. Bang, bang. Coming back. Okay. Yes. What can I do? Oh, that is the pointer. Just hold. Okay, so hold. Fine. So, perceived issues in there, generally in industry, is that using slightly flammable A2L solutions, the problem is, of course, flammability and the storage, transport, and technical training, and they plan to do that. What is euphemistically called here a non-flammable A1 solution, that is CO2. There is only one A1 non-flammable refrigerant in the world, and that is CO2. And I have taken the words. They say that it has technical challenges, that USA EPA SNAP approval is required for both low flammable refrigerants and CO2, and that manufacturer investment and system redesign may lead to higher costs for consumers. I would respectfully not disagree, but I would challenge that. And this is why I would challenge that. Maybe this is a moment to show that I am more on the forefront of technology rather than regulation. We have tried at CPS this. What is that? This is a 3.5 kilowatt, reasonably efficient COP of 3, small mini-split system, 410A system. And then we have replaced some components, and you will see what, and use CO2, which nobody would expect it would work well. We have added internal heat exchangers, and the rotary compressors with permanent magnets is the same type from the same manufacturer, just it was a 2-stage CO2 compressor. This is how it looked like. On the left side, you see the real evaporator. The same evaporator was used for 410A and for CO2. And on the right side, in the upper part, you see 410A original system in a baseline breadboard configuration, while gas cooler was with microchannels. And as you see, gas cooler was significantly smaller than the condenser for 410A. That had been offset with intercooler, which I say here at the bottom. The CO2 system had internal heat exchanger, intercooler, and two-stage compressor. What I want to show you are results. You see two colors here. One is blue and one is red, or whatever it is. Blue is CO2 and the red is 410A. And you see three sets of bars. This is for three conditions, rating conditions, A, B, and C. So in the same conditions, we have looked in the cooling capacity where results are shown on the left, and efficiency, which is shown on the right. I don't see any significant difference between these two bars. The conclusion is CO2 can make it at least up to 3.5 in a very simple system. Now you would say, how could it be possible? Give me a break. That cannot be true. Now this is a very simplistic presentation of what had happened in these systems. You see 410A is shown in red, and in blue is CO2. You see a slight difference in the cycle because of two-stage compressor with intercooler and internal heat exchanger. So ambient condition is 35 degrees C. So you see significantly better performance of a gas cooler than the condenser. Great effect of internal heat. I will try to point this. It is kind of strange. So this here is internal heat exchanger, and it is also here. The work is here. So that is a consequence of that is that we have a very, very low temperature before we have a very low temperature, much lower than the ambient temperature at the inlet to the expansion device. So it is possible. That's what I wanted to tell you. Okay, let's go back to what is happening in California. Commercial refrigeration. GWP 150 became a limit on new refrigeration equipment from 2022. A lot of incentives for low GWP refrigeration systems, and some manufacturers want to slow down this process through HRI. They push implementation further in the future, and they want to limit the charge over 25 kilograms for that. All of these parts that I am showing here on the left is a bottle cooler and then walk-in coolers in the display cases. They are very much affected by that. Now people in Europe could say, hey, what are you talking about? We have thousands and thousands of CO2 supermarkets. Yes, we do the same in the States, but maybe not as many, and there are so many other places where things should be improved and changed. What is very interesting, and I wanted to point that out, is the heat pump water heater area, where California requires all new homes to have heat pump water heaters from 2021, and some communities even 2020. This is all given in the energy building codes. Significant incentives are given and prepared for that. Overall, California has right now $300 million ready for various incentives for low GWP systems and high efficiency systems. What will, in my mind, be the consequence of that? We will have a reduction of the cost and improve the reliability of all of these systems. Technical push, as I say here, what is very interesting is they are pushing lower voltage because many homes, especially in the low-income housing areas, they don't have, because they have gas heaters, they don't have a need for higher voltage, which is 208 or 220 in the US is seen as a little bit higher voltage, but 110 volts. So now that is one of the directions, technical pushes to go into that, to go to lower GWP refrigerants, lower than 134A, which is a typical one, and typically it is 1234 ZEE that is looked at, and push for CO2. Just to give you some information about heat pump water heaters in the United States and say that this is different than what we know from Japan, where that area had started very strongly. And I'm showing to you here lots of many of these designs. Yeah, on the left side, you see a CO2 system. That system over here is a sentence system that is a CO2 system that is sold in the United States. Now we have here A.O. Smith in the middle as one of the, in two versions. These two are A.O. Smiths. And, but what is interesting, not only in the United States, now in China we see more and more, and this is Medea's system over here, second to the right, or this all the way to the right. It is very interesting. That is Gorenje from Slovenia. Very similar designs are seen also recently in Germany, and even, for instance, Daikin makes something similar, but this is different than EcoCute in Japan. From incentive, there are these two tools that regulators have in their toolboxes. One is carrot and one is stick. As a carrot, we have here, for instance, Efficiency Maine or Efficiency in Vermont. They are giving $600 incentive for heat pump water heater. And heat pump water heaters are typically, they started in the United States with a price of something like $2,000, $1,800. Now they are down to like $1,000, some are even $800, which is significant reduction, and I hope it will go even lower. But it is, when you compare it to gas or electric heat pump water heater, it is still much more expensive. I'll shift now to industrial refrigeration, and I'll tell you something about major elements that are happening there, at least in my mind. There are two. One is that CO2 is trying to go, and this is transcritical CO2 systems, or only CO2 systems, to go into that segment of industry. People and organizations on the ammonia side are sometimes concerned. Nobody likes a newcomer and challenges. We all like to have a competition to somebody else where we are buying, but nobody likes to have a competition in our own backyards. And in principle, CO2 shows efficiency advantages at low temperatures, and many people demonstrate cost effectiveness of carbon dioxide. The other direction is to go to package systems with the charge reduction. There is no universally accepted kind of definition of what is low on what is ultra low charge, and people are throwing these names and terms all around with no clear indication what that is. It is very often used in the commercial for commercial reasons. What is interesting in this change in industrial refrigeration, especially this one, drive is coming from user side. it is much safer to reduce enormous charges of ammonia. In industrial refrigeration, we are talking about tons, sometimes tens of tons of ammonia in one plant. It is very difficult to see these plants close to the city, or in some cases, especially in California, these cold stores in ammonia systems ended up somehow almost in downtown because of expansion of the cities. But some manufacturers love it because they see the opportunity for new business in almost unclaimed territory, because that territory is covered by the contractors and not pre-manufactured products. So this is one of the drivers that is happening over there. Still almost as many approaches as manufacturers. Everybody is now trying to come with a new design, new approach. I would rather say more to be different than for substantive reasons. What that means is there has to be change in that area. It has to come some consolidation, otherwise entire concept will be challenged, because there is no significant drop in the cost, which is expected when you start mass producing any product. I'm just giving you here illustration in a few slides. This is how it looks like in one distribution center in Long Beach. All of these boxes that you see are complete units. It is like rooftop air conditioning system, which is really placed on the roof. It is just much lower temperature and much more robust and higher capacity. Miniature cooling towers are there used to provide the water cooling systems, so to reduce the charge, because whenever you have air-cooled condenser, charge is compromised or can be compromised. I'm showing here the looks of the cold storage and the distribution center just before these rooftop units have been installed. The holes that you see here on the ceiling, these holes are the places where the rooftop refrigeration units will be placed. Typically screw compressors, compact design. Of course, we have evaluated all kinds of these systems, and this is how we have evaluated one of those. Everything is big. When you look on your left side, you see the huge number of 42 8-inch nozzles for ungodly flow rates, 50 cubic meters or kilograms per second. And you see here some equipment. All that equipment is even bigger than the very big rooftop refrigeration unit. Other solutions for ammonia charge reduction are to use cascades or secondary loops with CO2, and I'm giving you here one indication of how that is done by, obviously here, a Japanese company that will be presented here, I suppose. I could say this is really amazing change that industrial refrigeration industry is going through. Charge reduction is driven by users because of the safety. Many people are saying we don't want to see another Fukushima. In the case of the earthquake in California, leak of ammonia could be very dangerous. If you have tons and tons of ammonia, the ammonia in that panic would be the least that you want to see. So it is better to reduce the and dramatically reduce the risk. System design is driven by newcomers who want to take the market. Various ways to solve the problem. Too many players, too many solutions, as I said, and I have told you that earlier. Large chillers are gaining attention. These chillers are not based on ammonia. These chillers used to use 123 or 134A. Now, almost all of them are migrating towards 1233 ZDE refrigerant. This is a very low pressure refrigerant, lower than 123 or 134. Sometimes it is difficulty to operate because of vacuum in some cases, but you see all of them had kind of started from design of turbocore, what Rich Connery had developed back in Australia and New Zealand, and then moved to Canada and then sold his business to Danfoss. Now we have many of these compressors. You see here, I'm showing you that in blue is York, Train is in the middle in that whitish color, Mitsubishi Heavy Industry is on the right. Just to give you some illustration about how that looks like. And the second last slide is covering just briefly automotive sector. What I wanted to say here, AC systems in the US is settled on 1234YF as a refrigerant. We don't see too much interest in CO2 as in Europe, especially in Germany. But CO2 is knocking to another door. Electric vehicles in US are getting huge popularity like everywhere, and these electric vehicles require heating, and there is no waste heat, so it is the most logical to reverse the air conditioning cycle into heat pump and then provide the heating. But at this point, what is very interesting, it is a very undefined and diverse field of solutions. Almost every car is built in a different way. Electric car, air conditioning and heat pump in the car. So this industry will have many years to go until we see some uniformity as we see in conventional air conditioning systems. Many think this is a chance for CO2. Yes, I agree this is a chance for CO2. By far, CO2 is thermodynamically, technically the best option for low temperatures, but there is always competition. Refrigerant manufacturers are working on synthetic refrigerant side, and we work also on both on CO2 and these, and we see both sides of the problem. The real question is how low temperature is required from automotive heat pump. Is it minus 40? If it is minus 40, bad luck for any refrigerant than CO2. But if we set the lowest temperature that is kind of design temperature for heat pump at minus 20, then we can find some other synthetic fluids that can do the job nicely. So much more to be seen. Where will system go? And similar situation regarding electric automotives are in Europe and in East Asia. And in the summary, changes are accelerating, I would say, in our area, in refrigeration and heating, air conditioning. California is getting support from many states. So there is a lot of push in US. Industry had adopted changes, and it is ahead of federal government. Every segment of the industry is under the pressure and handles it pretty well. And for me, working in R&D and the science of improvements of these systems, great times are ahead of us. There are a lot of good opportunities for young engineers, for those who has the vision and entrepreneurial spirit. With this, I would stop and thank you for listening. and we'll be glad if there is any time for any question, if you have it. If you don't, we can talk whenever you want. I am not running away. I'll be here. Thank you.